Now, approaching this question, it doesn't actually tell us that it is the normal distribution. What we can see is there's a fixed number of trials, which tells us first of all it's binomial. Okay, and there's 250 of those. We're told there's equally likely male or female. Success and failure. Equally likely means going to be 0.5. So we've got the binomial, the large N, so we're now going to approximate. Look at the P. P is about 0.5 because it is 0.5. So we're going to use the normal distribution as opposed to the Poisson we'd use when P was tiny. So let's make this into your normal distribution of yn, and you can take my word for it. No, let's do it. So the mean is 250 times 0.5, which is 125, and your variance is going to be that 125 times 0.5, so that's NP, there's your Q, which is 62.5. Remember, of course, that is actually standard deviation squared because that is indeed already the variance. You may want to note to yourself, of course, that it may be useful at the start because you know you're going to transform it anyway. To make a note that the standard deviation is the square root of 62.5. So when you come to the end and you come to substituting in for the transformation of the data, you've already got a reference to use. I hope you don't forget, because often people forget, towards the end after all this work, to square root the 62.5. So next thing, continuity correction. Let's draw a number line. Okay, first of all, what we're looking for. So probably that more males than females, which must mean there's more that of 250 born, more than half, so more than 125 is going to be male. Again, I want to be greater than or equal to 126. So obviously 125 is not more, that's exactly males and females the same. More, so 126 males upwards, there's more males than females. On a number line, 125, 126, 127. I want more than 126 plus a continuity correction of half a unit, meaning for a y distribution, we're going to want to find out probability that y is bigger than or equal to 125.5. Don't do that. 125.5. Okay, then you're going to transform our data. So now we've got it into the normal. We know what we're looking for. We need to transform it into the Z distribution. Again, the Z distribution, we use the transformation of y take the mean over the standard deviation. So originally we had y is bigger than 125.5, where y is normally distributed, mean of 125, just see at the top there, and variance of 62.5. I said the standard deviation is the square root of 62.5. Okay, doing that now. Good. All right, let's transform it. Here we go into the Z distribution. So the probability using the Z distribution between two, no, we're not. We're going. I jumped too far ahead. Okay. So Z needs to be bigger than our Y value, which is 125.5. Take the mean, which is 125, all over the standard deviation, which is square root of 62.5. Okay, calculate that. You're looking for the probability that Z is bigger than 0.06. Well, let's draw ourselves a normal distribution. Let's see. 0.06. So the more than that is this section. Now our table only gives us a less than bit. So this red section is in fact 1 minus the probability that z is less than 0.06. Again, we jump to our tables and find that that is 0.5239, which is 0.4761. So, from the start, using our piglets, so in other words calves, using our calves, the probability that there are over half of the calves that are male is 0.4761. And a little additional thing here. Find the probability that exactly 110 males are born. The trick here is a constant. So using the same distribution, so just chuck that down again. So y is distributed n 1, 2, 5, 62.5. So your first thought might be, well, 0. Because I know in the normal distribution, the chance of getting an exact value is basically impossible. As we normally know that chance that y equals 110 is 0. Except if you've jumped to that point, you've not applied the continuity correction. Because probably that x equals 110. We had a number line, gave 109, 110, 111. 110 is there. Continuity correction either side means we're actually looking for data between 110.5 and 109.5. So in fact what we're after is a probability that y is between 109.5 and 110.5, which isn't 0, in fact has a value. Go ahead, apply continuity, give this a go. It's a bit trickier, and come back in 2 seconds. Now this was trickier because when you apply the transformation, you would have found that in fact you're looking for the probability that z is between negative 1.96 and negative 1.83. Remember, drawing graphs is massively important to the normal distribution. So I'm looking for the area between, let's use green, negative 1.96 and negative 1.83. Now, as we know, this isn't in our book. Okay, our book only gives us from 0 upwards. So you look at that, you look at an area on this graph, it's exactly the same as that. Okay, I'm drawing graphs all the way through, so it keeps it clear. You should do that as well. Because it is symmetrical, an area exactly the same as that is going to be the area that reflects from it. So between 1.83 and 1.96. So this is exactly the same as the probability that z is between 1.83 and 1.96. And now we know this. So we know from the table, we can find the probability that z is less than 1.96 because it's this area down there. We don't want all of that. We want this red area up here. So we've got to take away all of this stuff. So we're going to take away the probability that z is less than 1.83. Now you can jump to your tables to get a value for this of 0.9750 and a value for this of 0.96, is it 664? Yeah, 664. And then work out that that red area there and that green area there is 0.0086. So the probability that x equals 110, so exactly 110 male calves, is 0.008. 6.